Hello everyone, welcome to React, looping iteration. At the end of this lesson, you should be able to loop through data with React and conditionally display elements. Start with this first one, looping through data. Like fundamentally, we're doing the same things that we do when we're looping with other stuff. However, the thing that's a little bit different is that we're often working with data and trying to turn it into elements. And so, for example, if I have an array of data, one of the most common things we have to do is turn that into an array of elements. And hopefully you've realized by now that the whole JSX business is we just start writing the HTML that we want to have, and we can store it in variables and pass it around and all that kind of shit. So let's go over to our React app. Planets. Fire that up. Cool. Up and rolling. So, what boilerplate do I need to get rid of? I noticed that yesterday some people were deleting too much boilerplate. Yeah, Jackson.
The JSX minus div in app.
Yeah, let's go over here. Let's get rid of all this JSX. Cool. I also don't need that logo. I hang on to the app CSS. Cool. What else? Sure. We can. It's actually pretty controversial that they put this service worker in here by default. But if we do that, we also have to get rid of the import there. Okay. How about this CSS? All right. I don't mind the file being there, but I don't want anything in it. All right. Now we got a nice meat and potatoes app. So I can say the planets. Oops, where else is service worker defined?
What is service worker?
What a good question. So, oh, there it is. Service worker is a tool for, how do I put this? It intercepts all of your network requests and gives you a lot more control over them. For example, a really common service worker thing is, all right, I make a fetch request, my service worker can check to see if I have the response cached locally and just give me that instead. Or it can do that and then still make the network request, and if the response is different, update it. So we get a lot of fine-grained control. And one of the coolest things about that is that service workers work offline. So your web app can also work offline by just using cache data with your service worker. And if you would like to learn more about that, Ggressive Web Apps are the future. You go to videos. My wife said that this was very good TED Talk hands. Forget that. And then we had ES 2015, and then we had a 16 and a 17, but people don't really talk in. If you would like to hire so yeah, you can learn a lot more about service workers in that talk. That was at TechCrunch Disrupt 2 years ago. All right, so cleaned up a lot of this stuff. We got the planets showing up. Neat. So I want to store the planets as state. So what do I need to do?
Change the class.
Cool. I'm going to call on somebody to walk me through turning this functional component into a class component. Think to yourself for a second how you would handle this. Luke, what do I do?
Default export, or export default class.
I don't necessarily need to change the name.
Sorry, out.
Yep.
Extends. React.component.
Okay. Anything else?
We need a render.
Good. All right, neat, thank you. If you haven't figured this out yet, we can do React.component, or what's the other way we can do that? It's a little bit cleaner. Destructure it. How to destructure it?
React component.
Good. And then just do that, right? How does this work? That's kind of a curious thing. Any ideas?
Answer, yes.
Yeah.
So it looks in the React module,
Mm-hmm.
and then it grabs the, in this case, the class with the name component specific.
Correct. So yeah, somewhere in this React module, there's a named export named component that we're ripping out. We also have it on React. The React is the default export from the React module, presumably has everything on it. That's why we can do React.component, but it reads a little bit better if we yank it out. Jackson?
Can we take out export of default or class and do that at the bottom? Or do you need both?
Oh yeah, you absolutely should do that. You do one or the other, but not both. Good call. What else? Let's make some state. I'm gonna have some planets. And I'm gonna make an array of objects. All right, astronomy dork. What do we have? Mercury, is that the first one? I heard Pluto's back.
No.
It's coming back. No, you're trying to make Pluto happen.
It's coming back. Sometimes it's
Let's say it like Will Smith. Actually, here's the funny thing. God, this is going to be one of those kinds of days. Welcome to Earth. Everybody in the world remembers this as welcome to Earth. Listen closely.
Welcome to Earth.
Very cleanly articulated. I know the rest of the story. Jupiter, that next? Saturn?
Yes. Jupiter.
Okay.
Why did you give Earth ID 4?
Oh. Wishful thinking, I guess.
That's fair.
Okay, what's after Jupiter?
Saturn.
Then Neptune? Uranus? We're friends. We call it Plutes. Okay, so here's our planets. If I want to, actually, I'm going to add one more thing to these. Let's add a distance. Distance from Earth. We're just going to make things up. So we'll call this 300 call this 100, call this 0, call that 100. Then I think there's an asteroid belt somewhere in there, so it jumps way up. Actually, I saw something recently. It was like all of the planets could fit together side by side in the distance between Earth and the Moon. All right. Yeah.
What?
Yep. I think it was in one of my trivia books. I read lots of trivia books. All the planets could fit between Earth and Mars. Yep, there you go. And that's what it would look like.
Oh, that'd be chaotic.
All right, so we got a distance from Earth. So let's say I wanted to display all these planets, every one of them in a list. I want you to think about how I do that. Think to yourself. Rob, talk me through it.
Well, we would need to map through the planets, because yeah, we're doing the same
Mhm.
thing. So yeah, map through planets.
Cool, how do I map through the planets?
So we got this dot state dot planets
This dot state dot planets.
dot map open paren planet arrow function. And then at this point we need to, well, for each planet we need to take out, what do we want to get all the information or just the distance and the name?
Let's say their name. We're just doing name.
So planet dot name. So that's going to give us the information we need. So we just need to put it somewhere. Anybody want to chime in here? Anything on that?
Nope, stop right there. So thank you, Rob. Couple things, and this is like kind of the crux of what we're doing in this lesson. I want you to think about what you would change to make this work. Because this is the right idea. We're about 80% there, but this isn't it. Think about what you changed to yourself. Taylor, you got any ideas?
Why is that gonna work or not gonna work? Sorry.
I'm saying that this isn't going to work, but we're pretty close. What do we need to change?
I don't know.
Okay. Tyler, can you help him out?
We're trying to render those things inside that.
Yep. We've got a list of planets, and we need to turn those into a list of elements that have some data from the planets in them. We're most of the way there.
Should we wrap it in a function? Or,
Yep. So how do I do that? And pause real quick. Why do we need to do that? Anybody? Jackson. Why does this need to be wrapped in a function?
Because we need to call it in the JSX.
Exactly. You could also like assign it to a property or something like that, but right now we're just writing rando JavaScript in the middle of a class, and we can't do that. Okay? So Tyler, what am I going to call this?
just create planet.
Okay?
Create planets, rather.
Yeah, how about that? Maybe something like that?
We want to return the whole map statement as well.
Okay. So So that was another thing we got to do. We have to have the return in there. And we don't want to take that array of planets and turn it into an array of planet names. Think about what we're trying to do here.
Are these creating installments or
Yeah, sure. Let's do that. And so we'll make a UL down here. Planets. Oop. You were going to make this mistake at some point in the next couple weeks, probably a few times. What mistake did I make? Class name. JSX is just like HTML, except for like the very easy to forget times where it's not. And why can't I say class there? Reserved word in JavaScript. Okay? So yeah, we're going to do list items. Tyler, how do I wrap this?
so wrap in li tag.
Yep. And like that takes some getting used to, right? That's the JSX part of this. We don't wrap it in quotes. It's not a string. It's not the elements. It's JSX. We just write the elements kind of as is. And then right now, this is going to make 9 LIs that say planet.name. So Tyler, what do I do? Take this home.
Inside the UL,
Mm-hmm.
you want to call this not planets.
Okay. It's almost it.
We got to wrap that in braces.
Beautiful. One other thing we have to wrap in braces, planet.name. Okay, wonder if it worked. Womp womp. Unterminated JSX contents. So, let's go backwards through everyone who helped us out. Taylor, explain to me how this works.
Sorry, which part?
Let's start from here and then work backwards.
So the list of planets is calling on the function that we created called planets, which then takes the current state.
Pause real quick. Not a function, although like it looks an awful goddamn lot like one. This is a what? Starts with an E. Minor vocab quarrel. Expression. Good. So this expression, continue.
So it's calling, or it can start with this state planets, which is our object of planets that we created. And we're mapping through it, taking each individual object planet and returning the name of that planet inside an li element.
Wonderful. Mwah. Bravo, bravo, bravissimo. Thank you, Taylor. And then let's go back to, who did we start with? Rob. So Rob, the things that you missed on this, what did you miss?
We needed to make it an expression, and then instead of just after the feta in the code that just said planet.name,
Mm-hmm.
we need to return it and then throw it into a list element with some JSX.
Beautiful. All right, so we have iterated through this list of planets. They're showing up. Outstanding. So let's say this is a really common iteration pattern, and this will solve a lot of problems that you have in your front-end framework career. I'm going to give you a vocab word for this thing we just did, first of all. This is called a computed property. This is called a computed property. It's not the state. The state's up here. This is derived from the state. This is a computed property. This is a computed property. This is a computed property.
Is that a reacting or?
No, this is a like architecture pattern. Every single front-end framework has this concept. Things that are derived from state. You don't store them in state because we're starting to get into two source of truth territory. Geez, we just flashed back like 11 weeks. We don't want another copy of the planets over here. We want to derive a new thing from the planets. We want to represent them as list items. Or, the one that I'm about to show you, we want to filter those down, augment them, something. So we're going to do planets less than 500 from Earth. So we'll call this close planets. And so what's close planets going to be? Think to yourself for a sec. Kat, give me a hand.
Can you do, well, no, that's Rails. I was thinking like this dot state dot class dot find by,
Okay.
or dot select.
We don't have a select in JavaScript, but we do have,
Or e,
oop,
we do have filter.
filter, select, same thing.
Okay.
All right, so we filter, and how are we filtering?
By distance from Earth,
So how do I express that?
this dot state,
Well, I got the first part of this. Filter's going to take that lambda, that little function. What's the argument of that function? It's the same as when we did map.
oh, planet.
Yes. Cool, and then,
Are we doing the fat arrow?
Yep.
Okay, curly brackets, return.
and real quick, what are we trying to do with this filter statement?
Trying to filter by the distance from Earth.
Yes, so what's the expression?
Return planet distance from Earth greater less than
500. Cool. Awesome. So this gives us, that transforms that data. That's not the whole story though. So Kat, what else am I doing?
So it gets the data and we want to get the planet name back.
Yep. So what do I do?
Map.
Okay. And what am I doing in the map?
Map the planets, return planet names.
Okay. Cool. So now I've got planets. If I make that close planets, get the ones that are close by. Interesting thing here. Take a look at planets and close planets. Put your refactoring hat on. What sort of jumps out to you as, wait a minute, that's repetitive. Jackson?
Is that last part, return a line?
Yeah. Yeah. How would I, give me a way that I can refactor this.
Can you call instead of dot map called this dot planets?
No. Good guess though. Why?
Oh, because it's gonna call state again.
Yep. Also, this is an expression, and what's map looking for? Nope. Map takes one argument, and it is a data type?
Array.
Nope. That's what you call it on. It takes one argument. Nope. Well, I guess technically true, but what?
Placeholder?
Nope. What is this argument we're passing into map? What data type? Okay. Okay. What if I rewrite it as that? It's the exact same thing. What data type is this? It's a function. It takes a function definition. Map takes a function definition. Select takes a function definition. Reduce takes a function definition. Your big computer science word for this is applicative. Map is an applicative because it takes this function and it applies it to every single item in the array. Does not an object, it's not an array, it's not an expression, it's not anything else. It's a function definition. It's all that's happening there.
One more time.
Applicatives, like map or filter, apply a given function to everything, every item in the array. Okay, so we have this repetitive thing that we're doing. Yeah, Jackson.
Would we want to, so it sounds like we need to first get, it's like we have to pass closed planets into planets. Well, never mind.
I guess, like closed planets would be this dot planets dot filter. Because we already have the list elements and everything, we're just filtering out the ones that we want and then returning those list elements.
I'll also say that once something is an element, you probably don't want to do any more operations on it. We want to push that change out to the end. Transform the data, get the list whatever size we want it to be, make sure that the right items are included, and at the very end, once we've done all of those things, turn them into elements, like we're doing here. But this function definition, that's the repetitive part. So if I'm trying to refactor that, what do I want to do?
Take it off of both and create a new function.
I like that. So I can put this in the component. I generally don't. I'm not entirely sure why, but I like hoisting it from outside of the definition. So I'll go something like planet to list item and takes in a planet and does that. Now that I have that planet to list item, how do I use it?
In the dot maps, you can just put planet to list item.
Yep. It even reads kind of better. So I think I could read even better than that if I did the same thing with filter. How do I do that? How do I extract the function?
It'd be cool if you made a function where you could pass in any distance from Earth and then it would return that list. Just since we're doing it.
That's shit. All right, I'll show you how to do that. It's like kind of complicated.
Well, just like it takes in an argument.
Right. We'll do it.
Okay.
It's time. It's time.
It is time.
All right, so this expression, I want a function that returns that. Works the same way. So we can say is planet close? And it takes in a planet and returns that. And now I can yank that out and say, is planet close? And god damn, look at how good that reads. Like fucking poetry. Cool. So this is a very useful thing to know. However, I need to make it clear that the thing I'm about to show you is harder than this. This is out of scope for this lesson. So if your brain is exploding right now, maybe don't worry so much about this. But what Jeremiah wants to do is instead of having this be a fixed value, we want to pass that in like an argument. The challenge is planet close is a function definition. And what filter takes is a function definition. So I can't do something like filter 1000 and have that work, because then it actually calls the function and I just get the return value of the function. But if the return value of the function, so if filter is asking for a function definition and I need to invoke a function, what does that tell me about what the return value of that function has to be?
Can you ask that question one more time?
Sure. So it's a tricky one. It's a tongue twister. Filter needs a function definition. And the thing that I want to do is something like is closer than 700.
Do you add those parentheses in front of it? Like declare the function inside of there? I think you did that yesterday.
Yeah, use ES6 so it doesn't
Yeah.
call.
Declare the anonymous function within the filter?
So that's not any different than if I define it down here. I can define it inline or I can define it here. It's not really any different. But I'll tell you, this is the thing that we want to do with filter. We do want to give it a dynamic number for this, and we do that by invoking a function. However, if what filter needs to function correctly is a function definition, what does that tell you about the return value from this?
Oh, a function definition.
It has to return a function definition.
Oh, yeah.
So what we do,
Nice.
wait for it, is planet closer than, and we take in a distance, like that.
Ooh, yeah. That's cool.
That is cool. We have a function, we invoke it with a distance. The thing that it returns is a function definition that can see this distance. And it does it through what? Closure. This inner function has closed over this variable. Even though I invoked is planet closer than, it's done, doesn't exist anymore. That has been invoked, it is over. Still can see this thing that got passed in because it closed over it.
How does it know to take in the planet as well for the inner function?
Because this is a function definition, the filter function is going to call it and pass it each individual planet. But that's why it needs the definition, because it's going to call it. It's going to give it that argument. But now it can see the other one, too. Isn't that fucking wild?
That's
Nuts.
Because the first argument is a function.
Yes, exactly.
So it's calling the whole function with each item of what we're calling.
Exactly.
Okay.
But each one of those sees that same static distance that we passed in when we invoked it the first time. Up here. And if your brain isn't hurt enough already, here's the way that functional programmers tend to write that.
Oh no. This hurts.
That's the exact same thing. That's an arrow function right there, and it's the return value of that arrow function.
Holy shit.
Oh.
That's so cool.
That sucks.
Look at that. That's so cool. Why is it returning implicitly? Oh,
Because it's on the same line. You don't need curly braces. You don't need the return keyword. And then it turned into bedlam in the fucking Fox room. Students were driven insane.
That looks so good though. Like,
Oh.
it-
I can't look at that.
if you saw the whiteboard problem like that, would that be like instant job?
Depends on where. Because like I said, this is the functional programmer way they do everything. If you write Scala or Haskell or something, this is the only way you can write something like this. And this is frighteningly close to the lambda calculus, which is what all functional programming is based off of. Hey, what do you know? Arrows.
Oh, that looks so hard.
Oh, geez, okay.
But all that's really happening is something kind of like this, which regular humans would express as something kind of like that. And that's how, whenever you need to do one of these little applicatives, a filter, a map, or reduce, you need to give it a value, you have to use that pattern. Closures, baby. Coffees for closures. Love it. Okay. So, zip, 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 zip. Pretend I didn't say any of that. If like your head is just beyond right now, doesn't matter. The important thing, the thing I want you to take away from looping is this pattern right here. We have something in the state and we make a what was the keyword? Computed property. What's a computed property?
Derived from state?
Derived from state. This is the authoritative source of truth. We're deriving a new source of truth based on that. Cool. So that is looping through data with React. So conditionally displaying elements, this is substantially easier. And also like that ternary thing, it's worth knowing, but I have my misgivings about like, I don't know, whether that's actually that good a thing. So let's do this. Let's say while we're doing this planet to list item, it takes in the entire planet, and I want to conditionally render a little star next to it if it has rings. Sure, I like it. So let's see, does Venus have rings? Jupiter, Saturn, is that it? And Neptune? Does Neptune have rings? Uranus, that's right. All right. Yeah, I see some right in front of me. God don't make no dirt except you. Okay. And then in this list item, I want to got it. So I'm going to look up UTF-8 planet with rings. See if there's like an actual character for it. I'll bet there is. Astronomical symbols. Okay. Perfect. That's the sun.
These are legit UTF-8 characters.
There we go. Let me highlight that. Sweet. Yeah! Dope. All right, so I want that character to show up if the planet has rings. So, Huh. How do we do that? Ternary. All right. What am I going to ternary off of? Tell me what to type. Okay. Planet dot has rings, and then question mark. Cool. And then okay.
How about just planet.name by itself?
Yeah.
If there's not rings.
Well, I want the planet name to show up regardless, presumably. Still isn't going to work though. So you want it like planet.name or just planet name like that?
Yeah, that's right.
Can you just,
Non-refactored.
can you pull out the logic and then return two different like LIs?
Okay, we could do that. I feel like that's going in the wrong direction though.
No, don't do that.
Actually, that's more repetitive. It might also be easier to read, so we're going to look at it both ways. But this is still like a kind of a syntax clusterfuck. Why?
Repeating yourself.
That. Also, guess what? That question mark that starts off the ternary and this planet.has rings, it's JavaScript. If you're doing JavaScript, you have to wrap it in these things. Right now, I'm literally just writing the text planet.has rings. I know I am. So, I really want to do something probably more like that. Ah, where'd it go? Did it get maximized somewhere? God damn it. Mac has the worst leg. There. Annoying. Okay, parsing error. I typed something wrong. Yep, there it is. And Uranus, same thing. Cool. Oop. Since I'm in JavaScript land now, it's got to be a string. And actually more specifically, I should probably make that a template literal. And same, actually, it might not make me do it there. Yeah.
Oh my god. Let's go.
Pretty dope, huh? So, all right, that's one way we could have done it. Let's look at another way we could have done the conditional. Let's look at the way that Ethan was talking about it, where we just look at that and we actually return an entire li off of each one, like that. So that, or that. And this needs to go back into, oops. Shoot, no. Yep, like that. that, and don't need that. But I do need to close out the expression there. Cool. And neat. Okay. Look at that. Still works. All right. Between those two, I don't know, Ethan. Part of me kind of likes the second one better. I think that's a little easier to read. This is part of like, some of it's like my gripe with React in general, is that I think this reliance on ternaries in your UI logic is, I'll show you one more way you could have done this. Well, let's see. Do I want to do it that way?
It's kind of nice too, because you don't need to interpolate anymore, because you just directly do this.
Right. Yeah, I think that second one is a lot easier to read. The other way that you could do this would be to, instead of the ternary, you make this a function. I don't want to go down that rabbit hole. The way that this works in a lot of other languages is you're not allowed to put any logic inside of a template like this. And so what you do is for each one, you have like a, God, shit, I don't even know how to explain this. But you're always just referencing like, this planet's shit, and if it has rings, that was like way back up in this derived property thing, rather than putting it right in the template. But I think everybody's head hurts enough at this point.
Is it better to do conditional rendering in a parent or a child component? Does that make
I don't think I
sense?
could answer that without more information.
Okay, totally. Me neither. I didn't know if that was something. I guess, is conditional rendering like expensive to do?
No, not especially.
Okay.
One other way I'll show you could have written this one. This is kind of like the best of both worlds between that lambda calculus notation. Is this really doesn't need a name. And so you can just take that argument and fat arrow it, and then put that here. That's probably the most common way to write something like that. I didn't change anything. This is the exact same logic, but it both uses like a very easy to read function notation and some indentation and that kind of stuff, while also using that really dense lambda notation. All right, so our goal was to loop through data with React and conditionally display elements. What questions have you?
Which one's the best way for us to learn?
Sure. I would say, oops, already declared, no, yeah. Probably the easiest way to at least start, even if this is only a thing that you're doing while you're writing them, is to inline them the same way that you did in Mod 3. And then once you get that working, see if you can extract those things out into named functions like this. For looping, I'd say that's your best bet. And so you'll end up doing a lot of things like this.
And then on the bottom, those 3 examples though?
Oh,
Closer then?
sure. So I think I got rid of the other one. Do it a way that makes sense to you. That way this one right here, this is probably the best way to do it. but like you'll get there on your own over time. If like your head groks this a little bit better, that's fine. I wouldn't worry about it too much. And then for the conditionals, yeah, I like that one. But like that's close enough that like, because we could have also cleaned this one up a little bit more and said, so if I did something like that, oops, there it is. Like, that's probably a better way to write that version of it. But then I kind of want this to just be a function that this thing calls. So I think that, of the like conditional options, that one probably reads a little bit better. I'd go with that. But the first one is technically less repetitive. Oh shoot, one more trick I want to show you. This isn't actually like any different programming wise, but let's say this number right here is planet closer than. Let's say that's not hard-coded into close planets. Let's say that's state. So we say planet distance starts at 900, and then this becomes this dot state dot planet distance. And then in the template for this, there's like a slider or something like that that's bound to that and is changing that. The thing that people do wrong the most on this is they'll try to conditionally render this somehow as like, I want it to show all planets, unless like they start moving the slider, then I want it to be close planets or something like that. That never works. What you want to do is it's always your filtered list of planets. You just initialize that value so that like all of them are there. So if I've got something like this, the initial value of planet distance becomes whatever the most is, 1500. And now I'm incidentally showing every single planet, and as that value changes, it gets smaller. So like that's what you do for, I want to live filter results from a search as I'm like typing. What you do is you're always showing the filtered results, but it's like, I see students do this all the time. Like if nothing's entered in the text box, show everything. If something's entered in the text box, start showing the filtered results. No, if you make it so that you're filtering all of the results into a computed property so that like you're filtering by things that contain a blank space. Well, guess what? Every string contains a blank space. So you're already filtering everything. And then as you start typing, that list gets smaller. That's the big magic trick. Other questions? Cool, thank you.